Good morning. In this lecture series, we see about what is the meaning of finite element analysis, and also we have to study how the finite element is working, how we have to working with the finite element analysis. They call the short form is called as a FEA or FEM. The FEA stands for finite element analysis, and the FEM stands for finite element method. It's both are same. Okay. So first of all, we'll be discussing about what is the meaning of finite element analysis. So the finite element analysis is a powerful and computerized method to use to predict how the product is react with the real world forces. By the simulating these conditions, FEA shows whether it's a product will be break or wear out or functions as designed. This analysis reveals stress, strain, and displacement under the various loaded. You have to provide the critical insight into the structural behaviors. This method is working by dividing a structure into the smaller and more manageable elements. This is allow the engineer to appropriate solutions to complex problems with a greater accuracy. It is an earlier development in 1940 was driven by the need of aerospace industry, so make them to benefit beginning of this wide spread of using the various engineering field. Then coming to what is the meaning of financial analysis? Why need to we are to using for the financial analysis? So first of all, we are to going for the numerical techniques, then move for the mesh types. So when going for the numerical techniques, the FEA is a numerical techniques are used for solving the complex analysis problem. It provides the approximate solutions to boundary value of problems, allowing engineers to analyze the structures with interactive geometries with the load of conditions. But during the meshing, this process can be involved in dividing the structure into the finite analysis. For example, if I am considering the one-dimensional problem, I have to divide into two elements or three elements or four elements, five elements. Based upon your requirement, you have to divide it. Okay. This process can be known as a meshing. So whenever you have to increase in the mesh of the particular element, and also the accuracy of the given product also is good, more efficiency for the given analysis. Okay. And also these elements are interconnected with the node. So the element, each element having a two nodes. Okay. So if you're segregating the three elements means the node can be into two. What is the answer is called as a six. So that is called as a node. So that the element having each two nodes having that. The form the forming of a network with the represent the structural geometry equations are then solved for the each element. Then the result combined to the obtain and overall solutions, and understanding the basic of essential is engineering for seeking the optimization design and to predict the performance by leveraging this method. Engineering can make the information decision and also improve the reliability of their products. And then, what is the process I have to taking while I'm doing the FEA analysis? The foremost, the three processes are quite important we are using for analyzing the any product. Okay, that is the first one is pre-processing, analyzing, post-processing. So when we are going for the pre-processing, this stage is involving the creating the model and meshing into the finite element. So like a material property, boundary conditions, and loads are defined to the accurately represent the physical problems. So the second stage is we have to define for the analysis what we have to do. Either we have to going for the thermal analysis or going for the CFD, computer fluid dynamics analysis, or static structural analysis. Whatever you can do, okay, that type of analysis you can choosing for the second model, the second mode of analysis called as a analysis. These are numerical methods to use to solve the equations for the element. This steps is compute the stress, strain, and displacement value through these structures. Then the last topic is post-processing. The result are visualized to your provide the insightness into the structural behavior, mesh refinement, and improve the accuracy, ensure the reliable solutions. So that we have to doing for the three stages we are doing the effectively, and also we have to get the effective efficiency product we have to can be come from this analysis after completing this analysis. Okay, so the popular FES was I have seen a few examples. It's like ANSYS, Abacus, COM, SOL. Each of the following unique capability of different types of analysis. The mastering of these tools is crucial for the engineer performance for the FEA. Yes. So what are the types of FEA analysis and also linear static analysis? While going for the linear material behavior, the linear static analysis is assumed that the stress is proportional to the strain, the followed by the Hooke's law. This is the simplifications is a valid for the many material under the small loads. For going for the static loads, the loads are applied slowly and don't change the over time. This is allow for the straightforward analysis without considering the dynamic effects. So the basic structural analysis, this types of analysis is used for the basic structural assessment and design verifications. It provides a quick and reliable way to check if the design meet the certain stress and displacement criteria. So these are the classical example of stress analysis, the bridge under the static load, where primary goal of to ensure the structures can be withstand the weight of vehicle and its own weights. Yes. And also, what are the types of analysis? The non-linear analysis is like a material non-linear. The accounts for the phenomena is like plasticity and grip, where the material's behavior deviate from the linear elasticity. And also, the geometric non-linearity is address the large deformation that significant the alter the structures, geometry, and the stress distributions. The non-linearity, simulate the interactions and the contact between the parts which can be introduced the complex stress pattern. The non-linear analysis is essential for the simulating the complex scenario such as car crash where the material yielding the larger deformation. Yes. Then the type of finite element analysis for the dynamic analysis. So these are the basic three parameters we have to analyze. One is a model analysis, transient analysis, and a harmonic analysis. While going for the model analysis, determine the natural frequency and the mode of shape, structure, and critical for the avoiding resonance. And the transient analysis, the simulate the response of a structure to sudden impact of the loads, such as the hammer striking a beam. The harmonic analysis, these types of analysis is a response to the structure to the sinusoidal load useful for the understanding the vibration behavior. So these are the example of vibration analysis of engine where the dynamic analysis helps to engineers to understand and mitigate the unwanted vibration to improve the performance and reliability. Yes. So we have to discussing different types of analysis. We have to conclude this section. We have to wind up the application of find analysis. So based upon your application, I have to choosing the different types of software is available and different types of mode of analysis also available. We have to study. No, that is the three basic steps we have to study. Yes, correct. So pre-processing, analyzing, post-processing. The pre-processing is the mostly common method. Is there is only changes. If you want to change a material, if you change the structure, you want to change in the first process called as a pre-processing. Analyze what type of analyze what do you want to analyze. Okay, it's like a aerospace component, it's like automobile, automotive, or civil engineering or biomedical. Whatever you want to what you can go for the analyzing the perfect choosing part, then you can move the analysis part, then the final result will be more effective for your given product. Okay, so I shows the few example here. So the first one is I show as a aerospace, the aircraft structural analysis and design ensure the safety and performance under the extreme conditions. So these are the most useful for the aerospace industries. And the automotive industry, we have to use with the crash worthiness simulations and the component design enhance the vehicle safety and durability. While going for the civil engineer, the bridge building analysis, ensuring structural integrity and safety in the infrastructure project. The last one is the biomedical. So the biomedical, the implant design, the biomechanics analysis, improve the functionality and longevity of the medical devices. So the FEA is extended to consumer product, aid to the product design and the performance testing to meet the quality and the safety standards. It is a versatility make it the indiscipline to the tool access numerous industries. Thank you.